Now, so what is exactly is the rational motion? The rational motion, from its name or from its word, you can describe that it's any object that can rotate or spin. So if you have it, so if from its name, it is an object that can rotate or spin. So if there's an object here, it will rotate or spin. So that is the rotational motion. It's different than from the linear motion because it's simply the linear moved around or moved forward a linear motion, and it's translational motion. So we have two types of motion. We have an angular motion or rational motion, and we have a linear motion. They have the same things. We have a transition of the object from a position to a position. Now, so there are some terms that they are common between the rational and between the linear motion, that they have the same. Oh, that's mean they have displacements. That's mean we have a position. So let's say that this is a line. That's a line that say that is an tell me about the linear motion. And when I have an object, the object starts moving from this position up to this position. If we name it, this is with x initial and this is with x final. So that's mean that the delta x will be v, x final minus x initial, which we call it the displacement. So the linear displacements will be the difference between the final and the initial position. This is for the displacement is the difference between the final and the initial position. Now, as we have as a displacement and the positions for a linear, we have the same for the in rotational motion. We have the same terms. There's an angular position and there's an angular displacements. So let's say that there's a point here, which is point A, and there's a point here, which is point P. This is now at A. This is the initial position, and B, we have a final position. Now, A, we'll call it now an angular position, and the displacement will be angular displacement. The previous one, it was linear displacement. Now, we have an angular displacement. Now, so if we have it here A and B, so when I want to find the displacement between them, I mean that it is this way from A to B. So now let's name that the angular or the position of A, we name it with theta A, and the position of B, we name it with theta B. So, and the angular displacement will be delta theta, which is theta final, or the angular displacement at the final minus the initial. This is here how to find, this is, I will repeat, this is, we call it angular displacement. And this is here the linear displacement. So both of them have the same terms, but for the linear, we have x final minus x initial, and for the angular displacement, we have the final displacement, final minus of angular displacement minus the initial angular displacement. Now, if I asked you now, what is the unit or the standard unit for the linear displacement, you'll tell me that it's in meter. So if I'm talking about the linear here, so delta x, its unit is in meter. But for the angular, the unit for the rational, or you can say rotational, yeah, displacements or angular displacements, its unit is radian. Now we can use a degree, but the most common is radian. Now, so this is an measure of angles. It is not like measure of distance. In the linear, we are talking about measure of distance, this displacement. Here it's a measure of angles. This is, we call it angular displacements, and its units is radian. Now, next term that you need to be familiar with the angular velocity. Like as we have an angular and linear velocity, we have an angular velocity. And angular velocity tells you how fast an object is spinning or a circle, whereas how fast an object is spinning or a circle, whereas this is, we call it angular velocity. So we have here now this one here, we have a circle. For this circle here, we have, and since we have an angular position, angular displacement, we have also an angular velocity. So I tell you about, now what's the difference between them? The linear velocity is tell you about how the object is moving forward or backward. Here is tell you about what is the measure, or how, what is the, what is the measure that the object is rotating or spinning around the axis. Now, and all of us know that if I need to find the, let's move this one here, this is for the angular, and here we have a linear displacement. Now, and all of us know that if I want to find the linear speed, it's the distance. If you want to find the linear speed, it is a distance over the time. This is the velocity or the linear speed, which is a velocity distance over time. This is for the linear. Now, what about an angular? What you have to do? For the angular here, we have the same, but we call it now angular velocity. The angular velocity now, its formula is, when we don't write it as V, we write it as W. So it is, we write it in Greek, we say it's omega. So for the angular, we say like the omega, which means the velocity, that's going to be the average angular velocity, is equal to the angular displacements, which is delta theta, over the average in time. So the linear, we name it as V, which is the distance over time, and the omega, which is an angular velocity, which is an angular displacement over time. Now, what is the unit for the linear? We say that the unit is meter per second, and for the angular velocity, its unit is a radian per second. Now, and there are other terms that you need to know about the rotational motion. They are the period and the frequency. Let's start with the period. A period is a time it takes to complete one cycle. So if you have the total time over the number of cycles that will make a rotation. If you have the total time and the number of cycles, that you will make a rotation. And if you divide these two on each other, you will get a time that takes to complete one cycle or one full rotation around the circle. So the time that you need to complete one circle or one cycle or one rotation or one complete cycle will be called the big or capital T, which is the time over a cycle. This is time. It's mean the total time, and this is the number of cycles. If I divide them on each other, I will repeat. I will find the time for one complete cycle or one complete rotation. Now, the second term is the frequency. So the first term, which is a period, which we say that it is T time over the cycle. Now, this is the first term that you may know it for the angular motion. Now, let's talk about the frequency. Frequency is the reciprocal of the period. So the frequency is the reciprocal of the period. We can say the frequency is the reciprocal of the period. It is the number of cycles that occur per second. So if you have the number of cycles and you divide them by the time, you will get the frequency. So the frequency is the number of the cycles over the time. So now what's the unit of the period? The unit of the period, since I'm talking about time, it's a seconds, but actually it's a seconds per cycles. So the units for the periods, this is the periods here. And the unit of the period here is a second per cycle, or you can say second per revolution. Revolution. Now what's the unit of the frequency? The unit for the frequency is hertz. And we write it as Hz. This is hertz, which is 1 over seconds. So the period is time over cycle. Its unit is second per cycle or second per revolution. A frequency is a reciprocal of the period. This is the second term that we have to know it. The frequency is the number of cycles over time, and its unit is hertz. Hertz is mean 1 over seconds. Now, so also you can, let's come back to the angular velocity, the omega. You can also find that the angular velocity omega is, if you know the frequency, you can say it is 2 by times the frequency. This equation, you must commit the memory. So omega is 2 by f. If you know the frequency, you can find, I will repeat, this is omega, it is the angular velocity. It is an omega. So if I know the frequency, I can find the angular velocity with 2 by times the frequency. And since the period is 1 over the frequency, so I can say that you find omega as 2 by over the period. So we have here now, we learn another two equations that I can use, or two formulas that I can use in order to find the angular velocity, 2 pi times the frequency, or 2 pi over the period. Now, so far, for the angular motion, we talk about the angular position, the angular displacement, the angular velocity, the other two terms that you must need them in when you talk about rotational motion, which is then period and frequency. Now, since we have an angular velocity, we must have an angular acceleration. So let's talk about the angular acceleration and the linear acceleration. We know that the linear acceleration, which is A, is a change in a velocity over a change of time. This is a linear acceleration. And for the angular acceleration, which name it with alpha, is a change in angular velocity. So it is a change in angular velocity over change of time. This is an angular acceleration. So the angular acceleration, its formula is omega final, whereas omega is an angular velocity. Here you have to change the names that you know it for the rotational. Omega final minus omega initial over delta t. This is for the angular acceleration. And for the linear acceleration, we have v final minus v initial over t. Now, what about the units? The units for the linear acceleration, as we know before, is a meter per second squared. And the unit for an angular acceleration will be radian per second squared. Is it clear?
Yes, teacher. But I have a question. The angular acceleration, is it called alpha? What is the letter? Like the Latin letter for it?
Alpha. It's, you know what's alpha?
Yeah, I think it's that letter, or no?
Yes, I saw it in the book, that letter. If you maybe some of the books written at another, what is the another one?
No, I remember it as alpha, but I just wanted to make sure. Thank you.
Okay. Now, let's now let's now repeat here, but in definitions. The angular displacements. So as I told you, there's two types of motions, angular and linear motion. The linear, we have a distance, we have a velocity, and we have an acceleration. And such as we have a linear, we have the same in the angular and the rotational. But we name them now with angular. Angular because it's moving a circular motion on a circular path from angle to angle. That's why we name it with angular. Now, here it has a displacement, as we call it now, angular displacement. And it has an angular velocity, and it has an angular acceleration. So it has the same things as a linear, but in different names. Let's start now with the angular displacement. Its definition is the angle in radians, which is, it could be degrees and it could be revolutions, as I told you, but the most common is radians, through which a point or line has been rotated. So here, if you have an object that's rotate, did you remember the Earth, like talked about yesterday? This is a rotational motion. The Earth now start moving from this point up to this point. Do we have to find its linear motion? No, it is rotate. So it has an angular displacement. To find the angular displacement, it is the measure of the angle in radian from this point up to this point. So in the linear displacement, we talk about the distance from point to point. If you talk about angular displacement, you talk about a measure of angle from point to point. This is for the angular displacement. Is it clear?
Yeah.
Yes. Okay. Now, the angular velocity. As we have a linear velocity, we have an angular velocity. The angular velocity, we can find it as the difference. We have three formulas, as I told you. We have to say that it is a difference in the displacement, in the angular displacement over the change of time. As an example, I start at at 0 second with 2 radian. Up, I reach a 5 radian. So I start here with 2 radian as an example. I reached here with 3 radian in 2 seconds. So if I ask you now, what is the angular velocity? You tell me that the angular velocity, which is omega, its name now will not write V, it is an omega. Omega, it is a change of the angular displacement over change of time. So it's a 3 minus 2 over 2. So we have to say it is half. And the unit here will not be meter per second. It will be radian per second. This is
what is omega?
Omega, it is an angular velocity. We have linear velocity V. But for the angular, we cannot keep it as have this with the same name. We change it to omega, whereas omega is the angular velocity.
Okay, thank you.
Yeah. Now, and we have an angular acceleration. For the angular acceleration, we name it here with alpha, whereas the angular acceleration, we know for the linear, we have it's a change in velocity over time. For the angular acceleration, we have a change on the angular velocity over the change of time. So which is delta omega over t. Now there's a relation between the angular velocity and the linear velocity. That's in order to find the angular velocity, you can divide a linear velocity over r, whereas r is the radian distance. This is just an extra information to convert the relation from to convert from radian to angular to to linear velocity, just to say that the omega is v times r, or the velocity is omega times r. So in order to find the angular acceleration, it is a change in omega over the change of time. Now, here, if an object travels around a circle with an angular displacement of 70.8 radians in 3 seconds, so here the angular displacement, the change of angular displacement is 70.8. And a change of time is 3 seconds. I need to find now the angular velocity omega. Angular velocity omega is change of the angular displacement over the change of time, which is 70.8 over 3. Let's find it by the calculator, and so on. Divided the unit, don't forget the unit for the omega will be radian per second.
So teacher, the omega is the angle velocity, right?
Yes, this is the angular velocity. Now, the last question here. The angle through which a point or line or body is rotated in a specific direction around a specific axis. The angle which
Angular
object,
displacement.
wait, please. The angle where an object starts moving from point to another point on a circle. What we name it? Angular velocity, radian, angular displacement, or degree?
Displacement.
It is an angular displacement. Thank you. Is it clear?
Yes.
Yes.
Yeah.
Thank you so much.
Thank you,
Thank you.
teacher.
Thank you, teacher. Have a nice day.
Have a nice day.
Bye-bye.
Teacher.